Hello everyone. So today I'll be going through exercise 7.1 from this particular textbook, the AMATS textbook. So basically I'm just going to go through the basic questions from exercise 7.1. So this is for, I hope this video is useful for students who are trying to revise using the basic. So for this question one, they said that find the angle, right, that the line joining the point A and B makes with the positive direction of the x-axis. So for 7.1, right, we mainly learn this thing. So gradient equals to tangent theta, right? So for part A, right, we are going to sketch out, okay, the coordinates on an axis, on the y and x axis. So basically, it will look something like that. So y and x, then the a probably is like here. So let's say this is a, -3, 5. Then the b is probably going to be maybe somewhere around here. So this is b. Then 2, 7. Okay. So what happens is you draw a line that cuts through a and b. Okay, something like that. And then this is your theta. Okay, so they want to find out this angle. Okay, so first thing first, because gradient here, gradient equals to tangent theta. So we of course need to find out what is the gradient, right? So how to find out gradient? So gradient is equals to this formula, y2 minus y1 over x2 minus x1 equals to 7 minus 5 over 2 minus -3. And this will give us 2 over 5. Okay, so therefore, tangent theta equals to 2 over 5. Okay, which will allow us to find out what is our theta. So theta equals to tangent inverse 2 over 5. Okay, so just take note when you key in this, you got to make sure that the calculator is in the gradient mode. No, sorry, it's in the degree mode. Okay, so inverse tangent inverse 2 over 5, and then we will get the answer 21.8014. So we round off 21.8 degrees. Okay, so this is for part A. All right. Okay, so now let's move on to part B. So part B, basically, I'm going to do the same thing. We will visualize by drawing a sketch of coordinate A and B. Okay, so coordinate A and B. So for now, the A is 4, -3. So what happened? I'm just going to draw 4, -3. So let's see. 4, -3. So it should be somewhere probably around here. Here. Okay, so this is A, which is 4, -3. Then for B, right, is also B is directly on top, vertically on top of A. So here as well, so B. Okay, so B is actually 4, 6, right? 4, 6, right? Because based on their x coordinate, they are actually on top, directly vertically on top of one another. So actually, this is a very simple scenario where you draw a vertical line. Okay, I know it doesn't look like a vertical line because I'm drawing, right? But we should know, so I'm explaining that this is a vertical line. Okay, a vertical line. So when we have a vertical line, it means that this is 90 degrees. Okay. Yeah. So since this is 90 degrees, so it means that the theta is equals to 90 degrees. Okay. So also one thing to take note, if you do tangent 90 degrees, it will give us a math error. Okay. Right. According to the calculator line. So recall when we have a vertical line, okay, vertical line, the gradient is undefined, right? Yeah, so that's why, theta is 90 degrees. Okay, come, let's go through question 2 together. So determine whether the lines AB and CD are parallel. So take note, that means how we find out whether some line AB is parallel, right, to CD, it depends on what? Whether the gradient of these two lines is the same. Okay, so is the gradient same, right? So how do we find out? Of course, we got to find out the gradient of AB. Okay, so for part A, the gradient of AB is equals to y1 minus y2, right? So y1 minus y2 over x1 minus x2. So this is 2 over 3. Okay, as for the gradient of CD, okay, it is same thing, y1 minus y2, right? So y1 minus y2 over x1 minus x2. Okay, so this one is -1 plus 3, which is 2 over 3. So as you can see, both gradient is the same, right? So I will say, since gradient AB equals to gradient CD, right? AB is parallel to CD. Okay, this is for part A. Okay, can? All right, so let's move on to part B. So for part B, right? Same thing, we got to find gradient of AB. Okay, so gradient of AB equals to 7 minus 5 over 2 minus 1, which is 2 over 1, which is 2, right? So 7 minus 5 is 2, so 2 over, okay, yeah. So gradient of CD is equals to uh, 3 minus 4 over 1 minus 0, right? Which is equals to -1 over 1, which is -1. So as you can see, the gradient is not the same, right? So I will say, since gradient of AB is not equals to gradient of CD, I will say that AB is not parallel to CD. Okay, so yes, this is for question 2. Let's run through question 3 together. So in each diagram, find the equation of the line passing through point A and parallel to the line L. Okay, so for question 3A, right, they want us to find the equation of this line. Okay, so first thing first, the formula for equation of line is y equals to mx plus c. Okay, so m is the gradient, c is the y-intercept. Okay, just a quick refresher. Okay, so since this line L, right, this line L is parallel to this line, that means that they are what? The gradient is the same, right? So from here, right, what is the gradient of this line L? So the gradient of this line L, how do I find it? Y, so I rearrange this equation of line L. So y equals to -2x plus 3, right? So this will be the gradient of line L. So I can say gradient of line L is equal to -2. Okay, so which also means that the gradient of this line, right? The gradient of the line that we are finding here is also -2. So is y equals to -2x plus c. Okay, so this is the equation of the line that we are finding, right? Because the gradient of line L and the gradient of this line is the same. So that's why -2 is here. Okay, so how do we find the y-intercept? So we got to sub A, right, 0, 1 into this equation. Okay, so what happened? So 0, no, it's not 0. 1 equals to -2 bracket 0 plus c. So my c is actually 1. Okay, so therefore the equation of this line is y equals to -2x plus 1. So this is my answer. Okay, and a small trick. Okay, so without doing all this, there's actually one way you can find out also. So if you look at the diagram closer, right, this point A, right, is actually on the y-axis. So it means that what? Okay, let me erase all this. So it means that, right, this is actually also C, right? Which is the y-intercept. And this value is also 1 because of this coordinate 0, comma 1. Okay, so actually we don't need to do, this is not really needed lah. Not needed in this particular example. Okay, because they already tell us, outrightly what is the y-intercept. Okay, so let's move on to part B. Okay, let me erase all this. Okay, give me a while. Erase all this. Okay, can. Okay, let's move on to part B. All right, so same thing, right? The gradient of this line? Okay, the gradient of this line is, how do I find out? I rearrange the equation of the line, right? So I will have 3y equals to negative x plus 12. Okay, then I divide by 3 to all the terms. So y equals to negative 1/3 x plus 4. Okay, so what I'm basically doing is I'm trying to recreate this y equals to mx plus c for this line L. So I can spot or rather find out what is the gradient. Okay, so since these two line is parallel, it means that the gradient of the line the gradient of the line that we want to find is the same, right? So that means for this line is also y equals to 1/3 x, negative 1/3 x, right, plus c. Okay, but if you look at the diagram, this is not given to us, right? It's not like as if in part A, right, the y-intercept is given directly to us. Okay, so this is a little bit different, right? It's not given to us, so that's why we have to sub a known coordinate on the line, okay, into this equation. Okay, so sub A, negative 2 comma 0 into equation, okay, into this equation. So what happened is we have 0 equals to negative 1/3 times negative 2 plus c, right? So my c is actually equals to negative 2/3. Okay, so after finding out c equals to negative 2/3 means we have our equation already. So y equals to negative 1/3 x minus 2/3. This is the equation of this line. So this line, the answer is y equals to negative 1/3 x minus 2/3. Okay, let's run through question 4. Okay, so the question 4 says the point A, B, and C, right, lie on the same straight line. Okay, means visualize it looks something like that. Okay, so A is like 0, comma 1, B is like 2, comma negative 5, and then C is negative 1, comma C. Okay, we are drawing this just for visualization. I'm not sure who came first, so doesn't matter. Okay, that's not the point of this question. The point is, how do we find this C? Okay, so if you take a look, if A, B, and C, right, lies on the same straight line, it means that what? I can say that the gradient of AB is equals to the gradient of BC, right? Gradient of AB, which is like gradient of AB here, this part here, must be the same as the gradient of BC, isn't it? Because they lie on the same straight line, right? Okay, so how do I find out what is the gradient of AB? So gradient of AB, 1 minus negative 5 over 0 minus 2. Okay, so 1 minus negative 5 over 0 minus 2. Okay, which is equals to, what is the gradient of BC? C minus negative 5 over negative 1 minus 2. Right? So basically, I have created an equation, right, using this. Why? How? Because I know that their gradient is the same. Okay, so 6 over negative 2 equals to C plus 5 over negative 3. Right, so cross multiply, I will have negative 18 equals to negative 2C minus 10. Right, so 2C equals to 18 minus 10. Here, So 2c equals to 8, and then c equals to 4. Okay, so the value of c is actually 4. Let's run through question 5 together. So the point 2, comma 3 lies on this line. Okay, and this line intersects another line, right? Which is this 2x plus y plus 4 equals to 0 at point Q. Okay, then after that, the question wants us to find the length of line segment PQ. Okay, so first thing first, in order to find the length of line segment PQ, we definitely need to find out what is our coordinate Q. Okay, so basically, right, we have one line and another line. Okay, so let's say this line is your 3x minus 4y plus 6 equals to 0. And then this line here is 2x plus y plus 4 equals to 0. Okay, so basically this is point Q. Okay, this is point Q. All right, because that is the point where they intersect one another, right? Then your P maybe is somewhere around here. So this is your P. Because your P lies on the line 3x minus 4y plus 6 equals to 0. So your P will be probably here. Okay, so first thing first, we got to find out what is our coordinate Q. How? We are going to do simultaneous. Okay, because it is the intersection between two lines. Okay, so first thing first, let me see. Okay, so I'm going to let 3x minus 4y plus 6 equals to 0 as equation 1. Okay, then this 2x plus y plus 4 equals to 0. I'm going to tweak it a little bit. So I'm going to change it to this sorry. So I'm going to tweak it a little bit. So y equals to negative 2x minus 4. Okay, I'm going to shift all this to the right. So this is equation 2. Then what I do? Sub 2 into 1. Okay, equation 2 into equation 1. So what I'll have is 3x minus 4 bracket negative 2x minus 4 plus 6 equals to 0. All these are linear simultaneous equation. Okay, so if you are not sure, you might need to refer back. I think it should be in Sec 1 or Sec 2. I can't really remember, but it's one of the lower Sec chapters. So 3x, so expand all this out. So 3x plus 8x plus 16 plus 6 equals to 0. So 11x plus 22 equals to 0. So 11x equals to negative 22, x equals to negative 2. Okay, so you found the x. Now you need to find the y. So what do I do? Sub x equals to negative 2 into equation 2. Okay, so y equals to negative 2 bracket negative 2 minus 4. So y equals to, this is negative 2 times negative 2 is 4. So 4 minus 4 is 0. Okay, so therefore my q is just negative 2 comma 0. Okay, so we're not done yet, right? So how to find the length of line segment, right? So there's a formula that we learned. I'm going to shift this here. Okay, so the length of line segment is this lah. So square root, right? x1 minus x2 square plus y1 minus y2 square. So for PQ, it is equals to square root, right? 2 minus negative 2 square plus 3 minus 0 square. So square root. So this is, oh, I forgot the bracket here. Okay. So this is 2 plus 2, 4. So 16 plus 9. Okay. Equals to square root 25 equals to plus minus 5. Okay, but then of course your length cannot be negative, right? So therefore PQ equals to 5 units. Okay, so the negative 5 is rejected because PQ must be more than 0, right? Length of PQ must be more than 0. Okay, so therefore length of PQ is 5 units. Guys, so let's run through question 6 together. Okay, so the line L, right? Let me change my, yeah, okay, so the line L is parallel to the line x plus 2y equals to 6. So given that L passes through the point 3 comma 4, so L passes through 3 comma 4, find the coordinate of L, right? I mean of the point where L meets the x-axis. Okay, so basically, I mean, we can draw a small visualization. So let's say I have a line, um, probably like that. Okay, yeah, a line like that. And then this is line L. Yeah, line L. Okay, and then this is parallel to another line. Okay, and so these two line is parallel, and this line is x plus 2y equals to 6. Okay, and then the line L passes through the point 3 comma 4. Okay, so just a random point. So let's say here 3 comma 4. Okay, and then find the coordinate of the point where L meets the x-axis. Okay, so basically it could be something. Okay, I mean on the y and x-axis, right? Okay, L is something like that. So this is L. Okay, then probably 3 comma 4 is around here. So this is 3 comma 4. Okay, so this is the point where the L meets the x-axis. So they want us to find this coordinate. All right. So at this coordinate, we know that because this coordinate here, or rather this point, is on the x-axis itself, right? So the x coordinate is what we want to find out, but we know that this part, the y coordinate, is 0. Okay. So first thing first, we have to find out, okay, what is the equation of line L? Okay. So first thing first, we got to find out equation of L. Okay. So basically, how, right, is y equals to mx plus c, right? So we got to find out the gradient, which is m, and then c, the y-intercept. So how do we find the gradient? Okay, so very simple. We know that L is parallel to this line, x plus 2y equals to 6. So that means their gradient is the same, right? So basically, we're going to transform this line equation to y equals to mx plus c, right? So 2y equals to negative x plus 6. Okay, then y divide by 2. So y equals to negative half x plus 3. Okay, so from here we know that the gradient is actually negative half. So therefore, for the equation of L, it is actually y equals to negative half x plus c. All right, so how do we find out c now? So what do you have to do? Sub the coordinate 3 comma 4 into our equation of L. Okay, so so we will have 4 equals to negative half times 3 plus c. So 4 equals to negative 3 over 2 plus c. So c is equals to 5.5. Okay, so 4 plus 3.5. All right, so it's 4 plus 1.5, right, which is 5.5. So therefore, our equation of L is actually y equals to negative half x plus 5 whole and a half. Okay, so now we know that, okay, so how to find the coordinate of the point where L meets the x-axis, right? So we know that the y is 0. The y coordinate here, this is our y coordinate, this is 0. Okay, so what do we do? Start y equals to 0, okay, into our equation L, right? So we have 0 equals to negative half x plus 5.5. So half x equals to 5.5. So x is equals to 5.5 divided by half. Okay, so let me just do a quick one. So 5.5 divided by half. So it's 11. Okay, 11. So therefore, our coordinate is 11, comma 0. That's our answer for question 6. Okay. Okay, let's go through question 7 together. So point PQR have coordinates 9, comma 6, 15, 3, and 5, 4 respectively. So that means P is 9, comma 6. Okay. Q is 15, comma 3. And R is 5, comma 4. Okay, so we will visualize all this by drawing it on the Y and X axis lah. So, and then they go on to say that S is the point on the X axis such that RS is parallel to PQ. So that means from this point, we know that RS, gradient of RS is equals to gradient of PQ, okay? Because they are parallel. So let's draw all these points on the Y and X axis lah. Okay, so something like that. So this is P, and then this is Q. Okay, then our R 5, comma 4, it should be above Q a little bit. Okay, so here, this is our R. Okay, then let's try and draw a parallel line. So something like that, something like that. So seems like they're parallel. Okay, yeah. So basically they are supposed to be parallel. So parallel, and then this is our S. Okay, because S is the point on the x-axis. So let this be A, comma 0. Okay, so basically we got to find out what is our gradient of PQ lah. So gradient of PQ equals to 3 y1 minus y2 over x1 minus x2, right? So 6 minus 3 over 9 minus 15. Okay, so negative 3 over negative, no, it's not negative 3, sorry. It's 3. 6 minus 3 is 3, yes. 3 over negative 6, so negative half. Okay, then for gradient RS is equals to same thing, y1 minus y2 over x1 minus x2. So 0 minus 4 over a minus 5. Okay, so that means therefore, because they are parallel, right? So negative 4 over a minus 5 is equals to negative half. Okay, so let's do cross multiplication. So negative 8 equals to negative a plus 5. So a is equals to 8 plus 5. A is equals to 13. All right. So therefore, our S is 13, comma 0. This is our answer for coordinate S. Okay. There's a longer way to do this. So what happened is that for the longer way, right, we actually find equation RS. Okay. Before finding our coordinate S, which is a longer way, in my opinion. Right. So let's do that. So how do we find out equation RS? Well, let me erase all this. So equation RS, right, is y equals to negative half x plus c. Okay, plus c. How come? Because like I say, their gradient is the same, right? So they will share the same gradient of negative half, right? So then of course, how to find RS, right? We need to find what is our c. So we will sub R. Yes, R. Yeah, we will sub R, which is 5, comma 4 into the equation. So 4 equals to negative half times 5 plus C, right? So C is equals to 6.5, right? So our RS equation is Y equals to negative half X plus 6.5. Okay, this is our RS equation. So how do we find out what is our S coordinate? We need to sub S, which is our A, comma 0, into RS. Okay, so we have 0, not A, 0 equals to negative half times A plus 6.5, right? So half A equals to 6.5. A is equals to 6.5 divided by 0.5, half lah, right? So it's 13. So therefore, our S is still 13, comma 0. So you are supposed to get the same answer lah. Just that I find this a bit longer because you have to find your equation of RS first before finding coordinate of S. Okay. Okay, let's run through question 8. Okay, so question 8 is quite a mouthful to read. So the intercepts, okay, of a straight line at the axis, okay, so means the X and Y axis, they are equal in magnitude. Okay, means the number is the same, but opposite in sign. So means what? Means like it could be two scenarios. Okay, so these are the two scenarios. Let me draw out be easier to visualize lah. Okay, so let's take a look. Something like that. So it could be either this or wait, hold on. It could be either this or no, wait. Positive, negative, something like that. Yeah. Okay. So this is positive, positive. This is negative. Okay. This is negative. This is positive. Okay, that's basically what they mean. And then they are saying that okay, so first thing first, we got the opposite in sign. Okay, they are both opposite in sign. Negative part, positive part, negative part, positive part. Okay, but then they say that they are equal in magnitude. So that means what? The number here is the same. So for example, if this is 5, this is negative 5. If this is 10, this is negative 10. That's what they are saying. Okay, so I'm just going to let the numbers here be okay. First thing first, maybe let's use just the first scenario on top. Okay, doesn't matter. Okay, so first scenario on top, so let's just erase this and then all this. Okay, so we are going to let the number here be A. So this is A, this is negative A. Okay, and then they are saying that this line passes through 4 comma 5. So 4 comma 5, something around here, 4 comma 5. Okay, so they want us to find the equation of the line. Okay, so basically, so how do we do that? So y equals to mx plus c, right? Okay, so we of course have to find the gradient. So in this case, the gradient, how do we find the gradient? It's actually like that. So for this so-called two unknown points, we have what? This is something like negative a comma 0. This is something like a comma 0. Sorry, 0 comma a. Okay, 0 comma a, right? Because the a is the y part. And this is negative a comma 0. So how do we find the gradient? So the gradient is actually, so same thing, y1 minus y2 over x1 minus x2, right? So a over a, which is 1. Okay, so somehow the a gets cancels out, right? Because we know that they are the same magnitude, right? That's why. So our equation is y equals to x plus c. So what do we do? Sub in the known point, which is 4 comma 5, into the equation. So we will have 5 equals to 4 plus c. Okay, so 5 equals to 4 plus c. So c is equals to 1. So therefore, our equation is y equals to x plus 1. That's our answer. Okay, so usually students will see, hey, wow, how do we find the gradient? Because we got unknown points, how do we do it? So I will suggest that you try it out because the both number is the same. So you should kind of hope or wish that it will get cancelled out. And in this case, it did lah. So our gradient is this, which the A got cancelled out. Okay, let's go through question 9. So a straight line passes through the point 4 comma negative 3 and makes an angle, right, 45 degrees with the positive direction of the x-axis. So what is the equation of the line? So basically, it will look like this. Y and then x. So probably something like that. Okay, so they are saying that this is 45 degrees. All right. And then the point 4 comma negative 3 will be somewhere around here. Okay, maybe here. Yeah. 4 comma negative 3. Okay, so basically with the angle 45 degrees, we can actually find out the gradient, right? So the gradient is equals to tangent 45 degrees, which is equals to 1, right? So our equation is y equals to x plus c, 1x plus c, but I'm not going to write the 1. Okay, so what do we do? Sub the coordinate 4 comma 3 negative 3, sorry, 4 comma negative 3 into the equation. Okay, so we have we sub it in, right? So we have negative 3 equals to 4 plus c. So c is equals to negative 7, right? So therefore, our equation is y equals to x minus 7. This is the answer. I'll go through question 11. So given that the lines ax plus by plus c equals to 0 and dx plus cy plus f is equal to 0, and these two lines are parallel, right? So when they're parallel, same thing, the gradient is the same, right? So we are going to convert these two lines to look like y equals to mx plus c first. Okay, so for the first line, okay, let's label this as line L1 and L2, line 1 and line 2. So, 2. Yeah, so for L1, right? Okay, it is ax plus by plus c equals to 0. So I'm just going to shift things around. So by, right, equals to negative ax minus c, right? So y is equals to negative a over b. So everything will divide by b, right? Negative a over b, x minus c over b. Okay, so this is my gradient. This is my c, my y-intercept. Okay, then for L2, right, I'm going to do it on the right. So L2 is actually dx plus c, plus ey plus f equals to 0. So same thing, change it to the format y equals to mx plus c. So ey equals to negative dx minus f, then divide by e to everything. So y equals to negative d over e x minus f over e. Okay, so since they are parallel, since L1 is parallel to L2, therefore their gradient is the same, right? So therefore, negative A over B equals to negative D over E, right? Which also means that A over B, so divide times negative 1 on both sides or divide by negative 1 is the same. So A over B equals to D over E, shown. Okay, so this is for question 11. Okay, let's go through question 12. So show that the points A comma B plus C, B comma A plus C, and C comma A plus B are collinear. So what does collinear mean? Collinear means that all the points are on the same line. Okay, so example, something like that. So all the points are on the same line. Okay, so how do we show that? So first thing first, we must always show that they are all from a common point. They have a common point. And then also number 2, they have the same gradient. Okay, so I'm going to label this as A, point B, and then point C. Okay, so A, B, and C. So first thing first, they must have a common point. So I'm going to compare the gradient of AB versus the gradient of AC. Okay, so once I find out that, gradient of AB is equals to gradient of AC, I can say that, since AB, like line AB and line AC, right, they come out from the same point A, and then they have the same gradient. That's why they are collinear. Okay, so that's my plan. So how to find out gradient of AB? Okay, so gradient of AB equals to y1 minus y2. So y1 minus, okay, so this y1 minus y2 over x1 minus x2. Okay, so equals to b plus c minus a minus c over a minus b, right? Which is equals to b minus a over a minus b, right? And then this is equals to, okay, you can simplify it more lah. So negative 1 bracket a minus b over a minus b, and then you can cancel this out, and then their gradient is negative 1. Okay, so the gradient of AB is actually negative 1. So now let's find gradient of AC. All right, so gradient of AC. So A plus B, y1 minus y2, y1 minus y2, which is B plus C, over x1 minus x2. Okay, so A plus B minus B minus C over C minus A, which is just A minus C over C minus A, which is negative 1. So factorize the top. So C minus A over C minus A. So I can cancel the whole thing, and then it goes to negative 1. So you can see, right, gradient. So therefore, gradient of AB is equals to gradient of AC, which is -1. So I will say, since AB and AC is from a common point A and gradient, okay, let's write out in words lah, and gradient of AB is the same as gradient of AC, comma, the points, okay, the points are collinear. Okay, this is it for question 12.